Okay.
Yes, sir.
Okay, everyone. So today is the actual first lecture of acid and bases. We will talk about what is acid, what is base. Okay. So there are two things that we can talk about, right? The first is your school syllabus. Now, according to your school syllabus, you just have to know what is acid and what is base theoretically, right? As simple as that. But if you want, we will try to understand what is acid and what is base chemically. Okay, right, everyone? Okay. Now, before starting this chapter, okay, because in your textbook, we have the basic definition of acid and base and differentiation between acid and base according to your taste, right? But if you want to study in detail, right? Just let me know. Do you want to study in detail? Tell me, everyone. If you want to study in detail, so we can start with basic
Yes, so
terminology. What is
I
actually
want to
acid?
study sir.
Yes? Okay. Okay, everyone. And try to message. I have not muted you guys because I want a response from you. But please speak when I ask you. Okay, otherwise message. Right, everyone? Okay. So see, we started with what is atom, what is chemicals, right? That's what we started with. So I guess everyone know that atom have tendency to lose electrons or accept electrons to achieve stability, right? So we will just talk about sodium first. Sodium have tendency to lose electrons, so it will form Na plus plus electron, right? Because sodium will be stable when it is having 10 electrons, right, everyone? Hope everyone remember this, right? In the same way, when you talk about chlorine, so chlorine has tendency to accept electrons and form Cl minus, right? Because chlorine will be stable when it will have 18 electrons in total. Got it, everyone? Right? I hope everyone remember this concept because we have studied this in last class, right? Okay. Okay, everyone. Now you can just message me in co-host. Okay, everyone can message me in co-host. Yes, Ragini, if you accept, it is negative because the number of electron is increasing. Got it? The number of electron will be increasing, right? So if number of electron is increasing, I can say that if number of electron is increasing, I can say that the negative charge is more than the positive charge. So if negative charge is more than positive charge, then obviously the net charge will be negative, right? So for example, just talk about Mg. So Mg. So I'm writing this. So Mg, and this is your atomic number. So what's the meaning of atomic number? Atomic number means number of proton, right, everyone? So it will have 12 proton and 12 electron, right, everyone? Tell me, message, yes. Just raise your hand. Okay, very good, everyone. So all of you remember this. So tell me, what will be the tendency of magnesium? Mg is magnesium. So what will be the tendency of magnesium to lose electron or to gain electron? Tell me, to lose electron or to gain electron? Tell me. Now it is neutral now. This is neutral, right? Now it is having 12 electrons. Remember, it is having 12 electrons and it will be stable when it will have 10 electrons, right? So how can this magnesium, right, can attain stability? By losing electrons. Yes, very good. So it will become Mg. Now the atomic number, which is number of proton, will not change. It will be same. It will be 12 only, right, everyone? Because when we talk about exchange of electrons, number of protons remains same. That's the concept. So it will be 12 only. So what will change? So now 2 electrons will be removed, right? See this, 2 electrons is removed. Now if 2 electrons is removed, so I can say that there will be 12 proton and 10 electrons, right, everyone? 12 protons and 10 electrons. Anyone have any issue in this? Tell me. Anyone have any issue in this? No, right? No? So what do you think? What will be the charge on this Mg? Tell me. What will be this charge on this Mg? Vishka, I just said Mg removed 2 electrons, right? Alright, lost 2 electron. So what will be the charge on Mg? What will be the charge on Mg? Tell me. So now we have 12 positive charge and 10 negative charge, right? 12 positive charge and 10 negative charge. So I can say that we have 2 positive charge, right? Yes, very good, Ragini, because number of proton is more than number of electrons, right? So I can say that when we talk about any compound, there's exchange of electron. Yes or no? There's exchange of electron. Agree, everyone? By any means. It may be loss of electrons, it may be gain of electrons, it may be sharing of electrons. Right? Just think about this. I'll give you one example. Suppose we have Shravya and Ragini, right? Suppose we have Shravya and Ragini. Okay, this is case 1. Case 1. Now, Shravya have maths book, physics book, chemistry book, and one extra maths book. One extra maths book. Got it, everyone? Right? Maths book, physics book, chemistry book, bio book also. And one extra maths book, right? And Ragini is having physics, chemistry, bio. So she is not having math book. What will happen? Tell me. What will happen so that both of them can study well? Tell me. Arav, I'm just giving this example, don't worry, right? What will happen? Yes, very good. So Shravya will give one book to Ragini, right? Okay. So I can say that Shravya will give this book to Ragini. Okay. So if Shravya will give this book, so earlier Shravya had 4 books and Ragini had 3 books. Sorry, Shravya had 5 books and Ragini had 3 books. But now after giving, Shravya will also have 4 books and Ragini will also have 4 books, right? So both can study, right, everyone? Tell me, right, everyone? Okay? Yes, very good. So I can say that this is exchange of electrons, exchange of complete electrons. Shravya has given her book to Ragini. Got it? Right? Completely given her book. Okay? So I can say that this maths book now belongs to Ragini because Shravya doesn't need this. Right? Okay? This is case 1. Now just think about case 2. Case 2. Again, I'm having, suppose we have Arav and Madhur, right? Now Arav is having physics book, chemistry book, bio book, and Madhur is having maths book, physics book, chemistry book, right? So both are having 3 books, right? Now tell me, both need 4 books to study, right? Right, everyone? Both of them will need 4 books to study. Anyone have any doubt in this? No, right? Arav needs math book and Madhu needs bio book. So what will happen? What will happen? So I can say that Arav will share his bio book. So Arav will share his bio book and Madhur will share his maths book. Yes or no? So these 2 books, right, is shared by both, right? Right, everyone? Tell me, right? So in this case, they will share, right? Purvi, I'm saying that in this case, they won't give their book completely to each other. They will share because this math book, even Arav need to use this math book and Mother is also using this math book, right? Got it? So they are sharing this book. Okay, right? It's not that Madhur has given this book completely to Arav. Got it, everyone? Everyone got this, right? So, do you understand what's the difference between first case and second case? Tell me, how many of you actually understood the basic difference between first case and second case? In first case, book is completely given, right? Book is completely given to one another, right? Got it? And in second case, there's sharing. It is not completely given, it is shared. Got it? Yes, very good. Now this is what happens. This is what happens between atoms. Okay? Yes. So this is what happens between atoms. So atoms can either lose electrons or gain electrons or share electrons. Got it, everyone? So I can say that atoms can, or you can just say atoms or molecules. Atoms or molecules can either lose or gain or share electrons. Share electrons. Got it? Right? But why they are doing so? The question is why. Now just see in this case, case 1. If Shravya and Ragini are exchanging their books, or if Shravya is giving her book to Ragini, so they will become friends. Yes, they will stay together, right? They are friends, right? Friends. Yes or no? Right? Yes. In the same way, if Arav and Madhur are sharing books, they're also friends. Right? Got it? So they'll stay together. They have some kind of bonding. Yes or no? Right? And this bonding is, you can say it is friends, right? In the same way, atoms and molecules, okay, gain electron, lose electrons, or share electrons. Okay, gain electrons, lose electrons, or share electrons to form. Can you hear me, everyone? Loud and clear? Tell me.
Yes, sir, your voice is low. Yes, sir.
Yeah, I got a call actually in between. Right? Let's figure this out. Let me unmute everyone. Okay, everyone? Is it fine or it's still low? Tell me, is it still low? Still low. Okay. Now, now is it fine? Tell me. Now is it fine? Okay. Okay. I guess it's fine now. Right, everyone? All of you can hear me loud and clearly? Very good, very good, very good. Right? So yeah, so I was talking about this bonding. Now this is the most important concept in chemistry, bonding. So what's the meaning of bonding? It is the formation of compounds, right? Or it is the process in which two atoms come together, combine to form a bond, right? Right? Or to make a compound. Yes, everyone? Right? Very good. So I can say that to form compound, right, or molecule. Right, everyone? Okay. So let's see some examples. Let's see some examples. Okay. So we have seen the example of NaCl, right? We have seen the example of MgCl2, right? Manita, Mansa, I just said that atoms or even molecules, right? They either lose electrons, gain electrons, or share electrons. Okay, right? To form a bond. What is bond? Bond is kind of attraction. Okay, it's nothing but it's a kind of attractive force which holds the molecule together, right? For example, Na after losing electron, it will become Na plus, and Cl after gaining electron will become Cl minus. So it is positive charge, it is negative charge. So we know that positive charge and negative charge attract each other, right, everyone? Got it? So here, this attractive force is your bond. Okay, everyone? Right, everyone? Got it? Yes? Okay. So I hope all of you understood what is your bond, right? Okay. Now let's see. We understood what is compound. At least what is the reason behind the formation of compound, so that we can understand the basic concepts of acid and bases well, right? So let's start with types of compounds. Okay, types of compounds. So when we talk about types of compounds, right? Now this is the basic terminology, right? So I can say that we have two type of compounds. Okay, two type of compounds, or we can just stick to one category. Okay, there are many type of compounds. Okay, they based on different category, but for us we just want to focus on this category. So these three type of compounds are acid, bases, and salt, right? Acid, bases, and salt, right? It is not your just common salt. Common salt is also salt, right? But there are many other kind of salt. We'll see what is the basic definition of salt. Now, first of all, we have to understand what is this acid, right? Or what is this base? What is salt? So there was a scientist. Okay, can you hear me? Yes, you can hear me now. Message everyone. Okay, very good. So there was a scientist, right? When we talk about the compound, so there was a scientist. Now in like ancient times, right? Chemistry was not known as chemistry. It is known as, or it was known as alchemy. How many of you know this? Alchemy. Okay. And people perceive this something as magic, right? Alchemy has been related with magic because people didn't understand how things are happening. Okay. So people used chemistry to do some magic tricks. That's why it is called as alchemy. Okay. And even now, chemists are known as alchemists. Okay, so in ancient time there was a alchemist, or there was a chemist, or there was a scientist known as Arrhenius. Okay, Arrhenius. So if I ask you, what is acid? If I ask you, what is acid? Okay, so you might say, okay, sir, acid are those substances, right, which are sour in taste. Sour in taste. Yes, everyone, right? That's what you would say, no, because that's given in your textbook. What are bases? Bases are those substances which are bitter in taste. Bitter in taste, right? Okay, you have tasted, by the way. Okay, you have tasted it, but it is not possible. Frankly, it is not possible to taste all the acids because some acids are very strong. It can burn you, right? And some bases are also harmful. But this is a property of acid and base. This is not the definition. Okay. So you should ask, what is the definition? So according to the scientist, according to Arrhenius, right? He defined acid as compounds that can give H plus ion. H plus ion, right? Okay. So you might be thinking, what is the meaning of this? Right? Now just think about HCl. Just think about HCl, right? Now HCl. If you break down HCl, tell me what will be the components. Tell me everyone, what will the components of HCl? Yes. So it will be H plus and Cl minus. Yes or no? It will be H plus and Cl minus, right? Yes, this is called as hydrochloric acid. Hydrochloric acid. Got it? Right? Now tell me, according to Arrhenius, acids are that compound which gives H plus ion on dissociation. On dissociation. Means टूटने के बाद. Got it, everyone? Tell me. Everyone got this concept? Yes or no? Just raise your hand like this. Just raise your hand, everyone. Okay. Aditya, you can just watch the video once again and then make your own notes. Okay. Right? Charged atoms are known as ions. Okay. For example, sorry, I forgot to say that. My bad. See, in this case, sorry, my bad. In this case, sodium is your atom, but Na plus, it is charged. So this is called as ion. Charged atoms or molecules are called as ions. I'll just write it down. Okay. Ions. So ions are charged atoms or molecules. Atoms or molecules. Okay. And the same way, you should ask. Then there's a difference because here we have two charged atoms. Yes or no? Tell me. Two charged atoms, both are ions, but they are different kind. One is positive, one is negative, right? So according to that, you can say that positive charged ions are called as cations. Okay, cations, right? And negatively charged ions are called as anions, right? Cat positive and negative. Cations positive, anions negative. Got it, everyone? So tell me, Na plus is cation or anion? Tell me everyone. Na plus is cation or anion? Yes, very good. Very good, Madhur. Brinda, you're getting? Explain once again. Right? So I can say that this HCl, see this HCl, is breaking down into two ions, H plus and Cl minus. H plus is called as cation, hydrogen cation, and Cl minus is your anion. Wait. Chloride, anion. Okay, everyone? Got it? Tell me, got it? So now you know what is acid. So if I ask you, what is acid? Right? How can you identify that a compound is acid according to Arrhenius? So what you'll say? If the compound on dissociation will give you H plus, okay, will give you H plus, then that compound is your acid. But it is according to Arrhenius. Yes? Right, everyone? Yes? Okay. So let's see. If I'm talking about HF, right? HF will break into H plus plus F minus, right? So is HF an acid? Tell me, is HF an acid? Yes or no? Tell me, is HF an acid? Yes? Yes, very good. Very good. Yes. Now, let's see. H2SO4. Now, it will break into this. H plus plus SO4 or 2H plus. Because we have two hydrogen, no? Right? 2 minus. Now, in this case, is H2SO4 an acid? Tell me, is H2SO4 an acid? Yes? Okay, very good. So now you can know what is your acid, right? If someone asks you, what is an acid? So you can say that any compound which releases H plus on dissociation is your acid, right? Madhur, we will come to that. Don't worry, we will come to that. Okay? Now let's see. Now this is all about acid. What about bases? Bases. Okay? Bases. Now according to Arrhenius, right? According to Arrhenius, right? He said that atoms, compounds which gives OH minus, OH minus on dissociation means टूटने के बाद OH minus जो दे, right? Is your base, is called as R over R. Yeah. R called as bases. Got it, everyone? Tell me, right? Now let's see one example. NaOH. NaOH. So NaOH will give you Na plus plus OH minus. Tell me, okay, right? So I can say that this NaOH is giving OH minus. Yes or no? This OH minus is released when NaOH is broken. Right, everyone? So NaOH is your base. Okay, NaOH is your base. So we will study. See, I can either teach you actual chemistry, okay, and skip your remembering wala concept that you can learn from your book, or I can teach you whatever is given in your book. So choice is yours because you have limited time, na? Right? So what you want me to do? Tell me. What you want me to do? Everyone? because these things are not given in your textbook. Yes, everyone? So should I teach? Obviously, I will teach. I will teach important topics, right? Okay. I'll teach whatever is covered in book, obviously. Okay. I'm just talking about some remembering wala concept that you have to mug up. As simple as that. Right? Okay. So can I just skip those part in which we just have to mug up? Right? Because there's no point now. Right? For example, we studied heat thoroughly, we studied each and everything. Okay? We studied more than what is given in textbook. In case of this bio also, we studied everything which is given in book and something extra also, right? Mostly in bio we studied whatever is given in book, okay? But when you talk about physics and chemistry, there are many other things which is very important. So we will be covering both book and we will study extra, right? So whatever I'm asking is you have to you have to give some extra effort, right? Okay, to cover your school syllabus and you have to do good. Then only I can teach extra. Okay. If you won't do good in your normal school syllabus, then I won't be teaching anything extra. No. Got it, everyone? That's what I'm saying. Right? I won't be skipping any chapter. Okay, I'll just skip few chapters, topics which you have to mug up. As simple as that. Okay? Right, everyone? Or I might complete at end. Okay? Okay. So fiber, sorry, not fiber. Okay, yes, yes, Esther. So that's the definition. We'll cover those things. Don't worry. So I'll revise again. What is acid? Acids are compounds which give H plus after dissociation. Dissociation means breaking. Okay. What are bases? Bases are compounds which give OH minus on dissociation. Yes or no? Tell me. Yes or no? Right? Now tell me, out of these, which are bases, which of them, which of them are base, base or acid? Base or acid, right? Tell me. You have to tell me which is base and which is acid. Tell me. A. A is your acid or base? Tell me. A is your acid or base? Yes. Dissociation, Shravya. You have to break it now, right? Yes, very good. Ragni, that's the other concept. Okay. We are talking about which kind of acid and base, right? C. We are talking about Arrhenius acid and base. Okay. This is the first definition given by Arrhenius. There are other scientists who elaborated the concept, but these acid and bases are called as Arrhenius acid and base. Okay. This is your Arrhenius acid and base. Okay. It is given by, this definition is given by Arrhenius. Okay. Got it, everyone? See, A. A is releasing H plus, yes or no? So it is your acid. Acid. B. B is releasing what? OH minus. So this is your base. Yes, everyone. Third, it is your base because it's releasing OH minus. What about D? This is also your acid because it is releasing H plus. Very good, everyone. Very good. So mother asked one problem. Mother asked, what about H2O? Let's see H2O. Right? H2O. So even if you break H2O, it will form H plus plus OH minus. Is it acid or base? Is it your acid or base? You can say both or none, right? It is called as neutral substance. This is your neutral. Okay, this is neither acid nor base, or both acid and base. Got it? Right, everyone? Got it, everyone? Tell me. Okay. So I guess all of you, D is acid, na Manyata? H plus plus I minus. So it is releasing H plus. Okay, everyone? Tell me. Anyone have any doubt at this point? Tell me. Yes or no? So I hope all of you understood what is your acid, what is your base. Okay. Okay, very good, everyone. Very good. Let's see. Nifty, we will play after completion of this chapter. Okay. We'll try to complete this chapter as soon as possible. Just give me 1 minute. I'll open your textbook. Okay. So now we studied what is the basic definition. What is the basic definition of acid or base? Then what about definition? After definition, what we have to study? Properties. Got it? Properties. Right? You just see the properties. Yeah. Okay, everyone. Can you see the screen now? Tell me. Neutral means neither acid nor base. Okay? Okay, everyone. So see, when you talk about your syllabus just deal with property. Okay? Right? There's nothing like H plus or OH minus, all those things. It is just your property. It is not the definition. Okay? Now, how many of you know what is used to clean your room, like your washroom and all those things? And it might be given, right? Might be written in your this cleaning liquid that do not touch, right? Yes, detergents and acids, right? So actually acids are corrosive in nature. Okay, we'll see what is corrosive in nature. We'll see what is the property of corrosion. Okay, so let's see the substance around us. Let's see how acid bases are around us. First, let's talk about lemons. Right? Curd, lemon, juice, orange juice, vinegar. You all have tasted these things? Tell me. Yes or no? Tell me, yes or no? What is the taste like? H2O is not neither ace nor base, na, Brinda, that's what I said. It's a neutral compound. Okay? As I said, not all the substances are acid or base. Okay? It is just one category of compounds. Okay? For example, plastic. Plastic is not an acid or base, na? It is just one category of compounds. Okay? Yes, they taste sour. So actually it is a property of acid. Okay? So we will write it like this. Properties of acid and base. And base. So the first property, as I said, first property. Acids are sour in taste. In taste. Okay? Right? That's what we studied. So this is the property of acid. It is not the definition of acid. But for you, your syllabus, it is a definition. Okay? So according to your syllabus, substance which are sour in taste are your acids. Okay? But it is not always true. It is the property of acid. Means if you are saying acids are sour in taste, then that's true. Okay? Right? So you can say that acids are substance which tastes sour. Okay? Any issue in this? Right? Anyone? Okay. Now what about apple? Milk? Do you think milk has some acid? Tell me. Do you think that milk is having any acid? Because it's not sour, right? No. That's the thing, right? That's the thing. Since it's in your syllabus, things are not taught in very detail. You will say milk does not contain any acid. Right, everyone? But milk is converted into curd now. Right? Milk is converted into curd. Right? Got it? So there must be some kind of acid. Right, everyone? It might be very, very weak acid so that it is not that sour in taste. Okay? Now the acid which is in milk is called as lactic acid. Lactic acid. So you guys can write it down. Okay? Wait, I'll just write it down. Okay? So the most common acids that we eat, right? So in milk, this is lactic acid. Lactic acid. And second most common acid, right? Which is present in lemon, orange, or any fruit which tastes sour. This is called as citric acid. Yes, very good, mother, right? That's why these fruits are also called as citrus fruits. Right, everyone? Lactic acid is present in milk, Brinda. That's what I said. Lactic acid is acid which is present in milk. Okay, everyone? Got this concept? Tell me. Message to host now. Ragini, message to host now. Okay. So this was about acid. What about base? Tell me, what about base? It should have some taste, right? So I can say that bases, whereas bases are bitter in taste. Bitter in taste. Okay? Yes, example. So this example we have studied, right? Lactic acid. These are the acids that we have studied, right? We use it in milk. Citric acid, right? Lemon, oranges. Okay. Then HCl, hydrochloric acid. So where we use hydrochloric acid? Have you seen hydrochloric acid? Tell me, everyone. Tell me, have you seen hydrochloric acid? Yes, where? So hydrochloric acid is mostly used to clean your washrooms. Okay, yes, very good. Okay, okay, everyone. Now bases, tell me, an example of base? An example of base? This is baking soda. So baking soda is very common example of base. And then anything else? Yes. Someone say detergent. Okay, detergents. Then there's one most important and very common ingredient that we use daily. Okay, soaps. Soaps and detergent. Salts are other thing, na Yukti. Salts are third type of compound. Okay. One most important. Yes, very good, Devika. Very good, very good. Toothpaste. Okay, that we use daily. Right? So these compounds contain bases. Got it, everyone? Okay? Okay, everyone. Right? Okay. So till now we studied what is acid, what is base, what is the property of acid and property of base. So we just studied one property. Right? There are many other properties. Okay. So we will discuss all these properties one by one and how it is identified. Okay, everyone? But before that, we'll take a break of 5 minutes. Today we will be taking only 5 minutes break. Okay, because we have to play Kahoot also. So I'll try to complete the important concepts till 3:40 and then we will play Kahoot. Got it, everyone? It will take one more class. Okay, so we have a break till 3:10 p.m. Okay, everyone? Anita, there will be composition, right? Base will be there in hand wash. It's like that. So we will resume our class. So we studied that acid are sour in taste and bases are bitter in taste. Okay, and we have tasted some acid and base, some, right? But my question is it possible to taste each and every acid? Tell me, is it possible to taste each and every acid? Yes, Esther. Okay, tell me. No, right? Not at all. Because some acids are very harmful, right? Some acids are very harmful. Okay, everyone, please message on host from now. Please message on host. Okay, everyone. Okay, very good. So we know that. I'll just write it down. Okay, we'll just write it down here. It is not possible. It is not possible. Not possible. Okay, everyone. I'm loud, right? Okay. It is not possible to taste every acid and base, every acid and base for its identification, right? For its identification, right? Then what? Tell me. Then what? If we cannot taste each and every acid, then how can we know that this is acid or this is base? Okay, because see, when you talk about chemistry, we can't see H plus and Cl minus breaking down, right? Okay, because the properties because of this dissociation, but we cannot see that. It is not physical change, right? Okay, right? Is the basis also one, right? Yes, very good. So we need, right? We need some material, need some material, right? Which can identify, right? Which can identify acid and base. Yes or no? Tell me. Identify acids and bases. And bases. Okay. And these substances, these materials are called as indicators. And they are called as they are called as indicators. Indicators. Right, everyone? I'm audible, Purvi? Everyone, I'm audible, right? Tell me, I'm audible? I can hear myself? Okay. So if I ask you, what are indicators? What are indicators? So indicators are substance, right? Substance or materials or compounds which can identify acid and bases. Yes or no? Tell me. Yes or no? Right, everyone? Got it? Right? Yes or no? Yes? Okay. Very good. Now, when we talk about indicators, we will study in detail about indicators. So, I can say that indicators, indicators, right? Indicators are generally of three types. Three types. Three types. Okay. First, natural indicators. Natural indicators. Second, synthetic or man-made. synthetic or man-made. Okay, and third is called as olfactory indicators. Okay, right? Now I guess, except this, these two are self-explanatory. Yes or no? These two are self-explanatory. What's the meaning of natural indicators? Tell me, what's the meaning of natural indicators? Yes. So I can say that natural indicators are indicators which is present in nature or comes from nature directly, right? Yes, exactly. So I can say that natural indicators, natural indicators comes from nature directly, comes from nature directly, directly. Okay. Now, one of such indicators is used in every household. Every household. Can you tell me what is that? Yes, very good, Madhur. Right? Example is turmeric. Yes, very good. So smart. Everyone is smart. Turmeric. Okay, right? Now there are other indicators also, right? So see, we'll see indicators. So I can say that, right? Indicators are spatial type of substance which can test if a substance is acidic or basic, right? That's what I said, right? How it does so? Okay, so it does so by showing some change, some change. Okay, now that's the thing. Either it can be change in color or change in smell. Okay, so when you talk about natural indicator and synthetic indicator, it is change in color. Okay, now third type of indicator that I said, third type of indicator that I said, that is your change in smell. Okay, everyone, right? Yes, Gunnar is China Hospital. Okay, or we call it as Urhul ka food. I don't know how many of you remember this, like know this, but we, like I used to call this as Urhul ka food, Urhul ka food or Urhul ka food. Okay, that's very nice flower, right? We have studied that in, or we will study that in biology. Okay, because that flower is commonly used to study the parts of flower, petals, and then stamen and all those things. Okay, right? It's very interesting. Bio is very interesting. Okay, so what we study? What are indicators? Indicators are special substance which identify, right, or which test if a substance is acid or base. How it does so? How it does so? By changing its color or smell. Okay, right? So I can write like this. Indicators, indicators changes its color, change it, changes its color, right? Bracket में or smell. Okay, because smell is just for olfactory indicators. Okay, for these two, natural and synthetic, it is color. Okay, when brought in contact with, brought in contact with acid and base, acid or base. Okay, right? Right, everyone? Okay, we'll study it already. Don't worry, I'll give you all the examples. Okay, so see, these all are natural indicators. Turmeric, litmus, China rose, or Gurul ka fool, right? These all are natural indicators, right? Litmus comes from lichens, okay, right? Litmus comes from lichens, right? So see. Now let's see this. Acetic acid is found in vinegar, that you have to remember. Formic acid in ant sting. Citric acid we studied in citrus fruits. Lactic acid in curd, milk. Oxalic acid in spinach. Ascorbic acid in amla, and in tamarind, tartaric acid. So these all acids you have to remember. And as I said, if I ask you, will these acids release H plus? Yes or no? Will these H plus release H plus? Will these acids release H plus? Yes or no? Tell me yes or no. Right? Yes. Message to host, everyone. Right? I have changed the host. Okay. Yes. So for now, yes, you need to remember this order. So we asked, and this is important, right? So you will be asked that which acid is present in these substances. Okay, everyone, right? Okay. Now let's talk about base. See bases, right? So lime water. Okay, lime water. We have calcium hydroxide. What's the formula of calcium hydroxide? Can anyone tell me? Formula of calcium hydroxide? Hydroxide is OH. Calcium is Ca. Okay, so we will study how to find the formula. It is Ca, wait, CaOH whole twice. Okay, right? Whole twice. Yes, Brinda, I will upload it. COH ka whole twice. Okay, if you remember, Mg had valency 2, right? And same way, Ca will also have valency 2. Okay, now we have window cleaner, ammonium hydroxide, soap, we have sodium hydroxide or potassium hydroxide. Okay, yes, very good. Milk of magnesia, we have magnesium hydroxide. Okay, okay then. So this table you have to remember. This table you have to remember. Now let's talk about indicators. So the first indicator that we have to study is litmus. So litmus is actually your dye. What is meaning of dye? What is meaning of dye? Dye is a substance which changes its color, right? Which has some color, right? Or which changes its color, right? So we know that litmus will change its color. So usually this is a dye which is spread on a paper, okay? Paper strips, right? You might have seen this, right? Yes, dye means just color. Dye means just color, okay? So we use this dye or with this on paper. We spread it on paper. Okay, right? So now this will have some color. Now if you dip this in acid, suppose you have blue color litmus. We have only two colors in litmus, by the way. Okay, blue and red. Blue litmus and red litmus. We have red litmus. It's paper actually. Litmus dye is spread on paper. So it is like a paper strip, red colored paper strip. Okay, it will be looking, so it will look like this red colored paper strip. Okay, right? Then we will have another paper strip like this. Okay, now this will be your blue color paper strip. Right? So this color is due to what? Tell me. This color is due to which dye? It's not normal color. This is due to litmus dye. Got it? It is due to litmus. Okay. No, litmus is not a base. It is your indicator. It is your indicator. Okay. So I can say that. It is your most commonly used natural indicators. It is extracted from lichens. Okay. So the actual color, the normal color is purple. The normal color is purple. Okay. Right? Normal color is purple. This is the normal color of this dye. Right? Just I'm horrible at trying. Okay. So natural color is purple, right? But when you dip this in acid, right? When you dip this in acid, it will turn into red. Okay, got it? So this color will changes to red when it is dipped in acid, right? Acid will turn into red. Got it, everyone? Tell me, got this? Acid, right? And if this is dipped in base, it will turn to blue, right? Got it? So this you have to remember. This you have to remember. Okay? Right? Okay? So this is the actual color of litmus. Okay? When distilled in water. But we use these two color of litmus paper, red and blue. Now if you dip red colored litmus paper in base, what will happen? Tell me. If you dip red colored litmus paper in base, what will happen? Tell me. Let's see. No, no. See, forget about purple. Forget about purple. Right? I just said that. I will write over here. Litmus paper. Right? This is acid. This is base. Okay. In acid, it is red in color. Red. Okay. And in base, it is blue in color. Okay. So if you dip your red color litmus paper in base, it will convert into blue color. Yes or no? Right? Yes, it will turn into blue. Got it, everyone? Tell me, got it? Right? Yes, very good. Now, if you dip your blue color litmus into acid, then what will happen? Then what will happen? It will convert into red. Yes, very good. Very good. Okay. If you dip your blue color litmus into base, then what will happen? Blue color litmus paper into base. Yes, it will be blue only. It won't change any color. Ragini, depends on which acid or which base you are talking about. Both are harmful. Generally, acids are more harmful, but both are harmful. Both are corrosive. Okay? Okay. So this is your first indicator. Let's see other indicators. Right? I hope all of you remember about litmus. Okay? See? Red litmus and blue litmus. So this is the activity that you guys can do if you get your litmus paper. Okay. The second is turmeric. Now, how many of you have actually faced this? That when you're eating something, you got this stain on your clothes, turmeric stain, and then it turns into red. After washing, it turns into red. Tell me, have you? Is this happened? Have this happened with anyone? Right? It used to happen when I was a kid. I used to eat something, then I spread this dal or something in my on my shirt. Then after washing, it converted into the color changed into kind of red, right? Yes, Shravya, it is written now. It was your lichens only, right? It is your lichen only. See, it is written over here, right? See, it has a half color, lichens. I'm talking about lichens. Okay, I'm talking about this dye. I'm talking about this lichens. Okay, right, everyone? Shravya, distilled water means no ions. Okay, okay, right? So yeah, we studied these things, right? You can just test your litmus paper with different kind of substances. Okay, if it doesn't change color either to red or to blue, if red litmus is also not changing any color, if blue litmus is also not changing any color in some substance, then that substance is your neutral. Okay, Manita, I was just explaining the indicators. So I was saying about litmus paper. That litmus paper, red litmus paper, will changes to blue when dipped in base. Blue litmus paper will change into red when dipped in acid. But if both litmus paper does not change its color, then the substance is neutral. Got it, everyone? Right? So I can say that if both litmus paper do not change its color, then substance is neutral. It's neither acidic nor basic, which is your water, right? Normal water. Okay? Okay. The second is your turmeric. Second is your turmeric. Okay? So just think about this, right? When you talk about turmeric, have you used this thing? Have you ever saw the turmeric changing to red in color? Tell me, turmeric changing to red in color? Anyone? Yes? Very good. Very good, everyone. Many times. So why does it changes color? Tell me, why turmeric changes color? Why? What is the natural color of turmeric? Tell me, what is the natural color of turmeric? Yellow, right? Okay, very good. So let's see, because it is the same thing. Okay, turmeric, China rose, right? Everything is your indicator, right? So it will change color. So we will just make a table. Okay, we will just make a table and see what are the color. Okay, right, everyone? Right, everyone? Let's see. So before that, we will talk about synthetic indicators and we will make a table. It's better to make a table. Okay, because we have to click out also. Synthetic indicators. Synthetic indicators. Right? So, which is not natural, right? Synthetic indicators are your man-made indicators, है ना? Man-made indicators, right? Or chemically made indicators. I don't know why I'm making lots of spelling mistakes today. Chemically made indicators are indicators made in laboratory or made in laboratory. Yes. So such indicators, the example of such indicators are phenolphthalein. then methyl orange, methyl orange. So these are the indicators, right? Now, the important thing that we have to know, right? Arif, I'm not sure. Okay, I'm not sure. I have to check. Yes. Daksh, it is not indicator. It changes color because of the reaction. Okay, it's not that everything that changes color is your indicator. It's not like that. Okay, indicator specifically changes its color in acid and base. Okay, right? So let's make a table. Let's make a table. Everyone, wait. I'll just write it like this, right? So it is the name of indicator. Let's write indicator, right? Then acid, color in acid, and color in base. Okay, okay, everyone. So let's write. So first, we already know what is that. Litmus paper, right? It's litmus paper, right? Litmus paper. So in acid, let me complete this. Okay. In acid, it is which color? Red. Yes, very good. In base, it is blue. Okay. In the same way, turmeric. Turmeric. In acid, it is yellow, and in base, it is red. Okay. Right, everyone. Third, red cabbage water. It is also your natural indicator. So red cabbage water. When you talk about red cabbage water, its natural color is red, right? So in acid, it will be either red or pink. Okay. But when you talk about base, it will become either bluish green or yellow. Bluish green or yellow. Okay. So these are some natural indicators. Now, when you talk about man-made or synthetic indicators, so first and very famous is the methyl orange. Methyl orange. It's not orange, it's the color, right? Don't think that it is some kind of orange. So, as the name suggests, right? Tell me, what would be the color? In acid, it would be, it is red. In acid, it is red. Okay. In base, it would be yellow. So this is your table that you have to remember. Okay, everyone? Right? Then we have phenolphthalein. I'm just right. There are many indicators. Many. So these are some very common indicators that we have to study. Okay. I will send you the list of all the indicators. But these are the very common indicators that we have to study. Okay. And when you talk about Phenolphthalein. Okay, phenolphthalein. Okay, wait everyone. Yeah, phenolphthalein. So phenolphthalein is actually colorless. In case of acid, it will be colorless. But in case of base, it will be blue in color. Or it's actually purple or pink. It's pink. Okay, everyone? Got it, everyone? Right? It's like just like water. Colorless means water. Okay? Water is colorless now. Right? Got it, everyone? There are many indicators. There are many indicators. So these are some very famous indicators. Okay? Okay, yes, Kahoot time. I hope everyone enjoyed this. You have learned something. You understood what is acid, what is base, what are indicators? Yes or no? Tell me. Right? Okay. Let's play Kahoot. Everyone, be ready with your Kahoot. Okay. Be ready with your Kahoot. Ready? Very good. Just give me 1 minute to prepare Kahoot for you guys. So everyone is ready now? Yes, Esther. I'll share the code with you guys. Wait for some time. Just 2 minutes. Wait for 2 minutes. You can make Maggie in 2 minutes. But Maggie is not made in 2 minutes. It's a lie. Right, everyone? How many of you made Maggie in 2 minutes? Tell me. Have you ever made Maggie in 2 minutes? It's not even possible. Right? They are lying. Yes, it takes around, for me, it takes around 5 to 10 minutes. What is happening? Okay. Yeah, okay, the code is 107199. Everyone, just see the code 107199. Join everyone. Join soon. Okay, we'll play one more Kahoot. Ready, everyone? Right? Ready, everyone? We will see this screen. It will be visible on screen. Okay, very good, very good. Just wait for some time. Answer. It will be visible on screen. Just be patient. So all of you, the code is, everyone, the code is visible on screen. It is 556930. 556930. 556930. Everyone just join. 556930. Yes, very good. 14, 15 players have joined. 16, very good, very good. 17. Yes. 18 players have joined. I don't know who is Diligent Bunny. Who is Bunny? I don't know who is Bunny. I never thought that I'm teaching a bunny. That's quite an accomplishment. Who is Bunny? I'm teaching a bunny. That's cute, right? So yeah, so we have around 18 players. Let's start now. Right, the code. You can just see the code at the bottom of the screen always. Okay. Hi, Diligent Bunny. Okay, so let's start. Right, indicators. This is based on indicators. Yes, 3, 2, 1. Ready. First question. Turmeric powder, litmus are generally termed as litmus powder. Sorry, turmeric and litmus powder are generally termed as acid base or indicator. It's quite easy. Everyone should get the scores. Right? Fast, fast, fast. Everyone should get the full score in this one. Yes, I got 19 answers, 20 answers. Very good, very good. Right? So I guess yes. Let's see. 16. You guys made mistakes. How come? Right? It is indicator. First position, again Abhinav. Very good, Abhinav. Keeping the first position in both rounds. Right? Let's see. Second one. The indicators helps us to identify acid and bases. True and false. Okay, no, it is by change in shape, change in color, change in state, change in temperature. Right? It's easy. We just discussed this, right? Change in shape, change in state, change in color. Okay, 19 have corrected. Very good, very good. See the scoreboard? Wow, Amisha got first position. Very good, Amisha. Abhinav is not in the game now. Let's see. Litmus, a common indicator, is obtained from lichens. True or false? Fast, fast. True or false? Litmus, a common indicator, is obtained from lichens. Wow, I got 20 answers soon. Awesome. True, yes. Let's see the scoreboard. Wow, Yukti, first position. Wow, what's happening? Girls power. All except Nandish, all the four are girls. Fourth problem, second last. On adding acid, litmus being purple changes to blue. Litmus being purple changes to blue. Right? Acid, tell me. Acid, which color? In acid, litmus turns to which color? False, na? We just studied in acid turns red. Right? Let's see who's in the game. Okay. So Nandish is replaced by Misha. Last problem. Let's see. Last problem of today's Kahoot. All type of acid can burn the screen. Burn the screen. True or false? All types of acid can burn the screen. True or false? 20 answers within 3 seconds. False. Yes, we eat some acids, right? Very good. Let's see the scoreboard. Podium, third position. Madhur is third position in this one. Okay. Second. Wow, Amisha. Very good, Amisha. First. Let's see who's first. It might be surprising. Yukti. Very good. Very good, very good. Right? So, do you want to see the whole scoreboard? Tell me, do you want to see whole scoreboard? Let's see. Okay, let's see the whole scoreboard. So this was the whole scoreboard of last. Yeah. So see, this is the whole scoreboard of last quiz. Okay, this was for last quiz. So see, you guys. Okay. Okay. So let's see. So this is your report. See, we get reports like this. You will be able to see reports. Yes. So let's see who scored 100%. Wow. Wow. Outstanding. Right? 100%. Yukti, Amisha, Madhur, Aditya, Ragini, Rishika. Very good. You guys score 100%. Right? 100% correct answers. King Intelligent Bunny. Right? You guys need to buckle up. Okay. Very good. So I guess everyone got their answers, right? Okay. Thank you, everyone. That's all for today. I hope you enjoyed the class, right, everyone? Okay. Bye, everyone. Bye bye. Bye bye. Bye bye. Have a nice day. Yeah, yeah. One more notification. Okay, I'll just message in the group, right? About test on Tuesday. I'll just message on the group. Okay. Bye, everyone. Bye bye.